Okay, now we're going to look at other types of boundary behavior. We looked at reflection in great detail in the last video, but we're going to talk about refraction and diffraction and how it relates to reflection. So reflection, just kind of rehash, the wave hits a barrier and then it bounces off the barrier. Now when this happens, the wave that goes before the barrier is called incident ray, and you recall that the reflected ray is what bounces off. Now there's an angle that goes with this. It's not always a right angle, but we're going to see angles with this quite a bit. So they reflect in such a way that the angle at which they approach the barrier equals the angle at which they reflect off the barrier. And this is the law of reflection. So incident angle equals reflected angle. And when you get into optics, you'll probably talk about that a little bit more. Now when we have a curved surface, reflection does this similar, kind of like with mirrors and glasses. But they hit and then they'll bounce off at an angle. In this case, the angles will cross, and then you can see they'll come to a point where they meet, and that's called the focal point of a lens. And again, with optics, you see that a lot more. But off of curved surfaces, again, angle of incident is equal to angle of reflection. And we see these different phenomena happen with light waves. Refraction. Refraction is when waves change direction when they pass from one medium to another. Now this is important. Remember, when we change mediums, we change speeds. So what causes refraction, or the bending of these waves, is the change in speed. Now the speed changes because of the wavelength changing. Remember, speed, wavelength times frequency. The frequency of the wave stays constant. So if speed goes up, wavelength has to go up, and vice versa. Speed goes down, wavelength goes down. That's refraction. Diffraction. Diffraction involves a change in direction of waves as they pass through an opening or around a barrier in their path. So as they pass through an opening or around a barrier. So let me give you some examples of this. Let's say we have a narrow opening to a dark room. Okay, so this room over here is dark. And we shine a flashlight, so we shine a light through here. When the light gets to this opening, it actually gets smaller, and then it will start to spread back out. Now it won't light up the whole room. There'll be areas that are still dark, but it will put some light into the room. So this light waves, as they enter an opening and open back up again, that's an example of diffraction. Another example, and I'm going to use light again. If you're going around a corner in a dark alley or a dark hallway, and you have a flashlight, the flashlight hits here but doesn't keep going in this path. The light actually spreads out a little bit around the corner. Now it doesn't cover the whole space until you get closer, but this ability of light to bend around this barrier is diffraction. So reflection, refraction, and diffraction are boundary behaviors that involve bending wave paths. Now usually when the medium is 2 to 3 dimensional, we can see this bending of the path. Reflection is when something bounces off a barrier. Reflection off straight barriers will follow the law of reflection. Angles will be the same. If you go off a parabola or a parabolic barrier, and you'll see things bend with an unflat surface, what you get is convergence of waves at a focal point. Refraction is the change in direction that occurs when waves travel from one medium to another. That is due to changes in speed and wavelength. And diffraction is the bending of waves around obstacles and openings. And then the key point about diffraction, how much diffraction you get involves the increasing wavelength. So the longer the wavelength of light, or the longer the wavelength of the wave, the amount of diffraction you'll get. So the greater the wavelength, the more bending you'll get around the barrier.